Alright, welcome to 24.3, the training practice quiz. Question 1, in triangle ABC, measure of angle B is equal to 59 degrees, AB is equal to 7 units, and AD is equal to 6 units. The altitude, segment AD, is also a segment bisector of segment BC. What is the area of triangle ABC? Okay, before we move on, segment bisector means that it cuts that segment in half. So that means this is one half of its length, this is the other half of its length. So in geometry we would mark it like that so that we can remember that they are congruent. Let's just step through it and see what they are wanting our steps to be first. So in order to find the area of the triangle, you need to know the length of segment BC because triangle ABD is a right triangle and segment AD bisects segment BC. You can use your knowledge of right triangles to find the length of BD and then find the length of BC. So what their meaning is if I know the length of BD, then I know that length is also the length of BC, so that I could just double it to find the total length of BC. So that's why it's wanting us to first find the length of BD. So I always start myself in a triangle situation. Is it a right triangle? If the answer is yes, and am I solving for a side length? If that answer is a yes, then we have two options. We have the Pythagorean theorem, or we have sine, cosine, tangent. We have the trig functions. Now, what is required for the Pythagorean theorem to find side lengths is we have to have two known side lengths. For the trig functions, we have to have one known side length and one angle besides the 90-degree angle. So if we look at this, triangle BDA, notice I have the side length of AB, which is 7, and the side length of AD, which is 6. So that meets the Pythagorean theorem requirements. Also, it meets the trig functions requirements because we have this angle of 59 degrees and a side length. At least one. We have two of them. So we could use the Pythagorean theorem or the trig functions. It just depends on which one you are more comfortable with. I will do the trig functions. I'll show you the step on that, and then I'll show you the steps for the Pythagorean theorem. So for this one, I'm looking at this and I'm asking myself, okay, well, from 59 degrees, what are the sides going to be labeled as? We always know that the side length across from the 90-degree angle is the hypotenuse because it is the largest side. The side length that is directly across or opposite the angle is going to be the opposite side. And then the one that is touching the angle, that's not the hypotenuse, is the adjacent side. So we want to find the adjacent side length. We have the choice of either using the opposite side or the hypotenuse. With the trig functions, you have sine, cosine, or tangent, and I use SOHCAHTOA to help me remember that. So SOHCAHTOA, sine is opposite over hypotenuse. I'm not going to use that because I have the opposite and it doesn't help me find the adjacent side length. Cosine is the adjacent side length divided by the hypotenuse side length. I'm going to use that one because I want to find the adjacent side length and I have a hypotenuse side length. So we have cosine of 59 degrees is going to equal, let me insert is going to equal the adjacent side length, which I do not know. I'm going to label it as A, and the hypotenuse, which is 7. Okay. So we have cosine of 59 degrees is equal to A divided by 7. So how can I solve for A? Well, if it's being divided by 7, I'm going to multiply both sides by 7. So I would take this, multiply it by 7, and I would take this whole side and multiply it by 7. What does that do? That reduces 7 divided by 7 reduces down to a 1, so that we are left with 1A, and most commonly it is just written as A. The 1 is implied. If I have an A down, I have at least one of them. So I would use my calculator and type in 7 cosine of 59 degrees and make sure I'm in degrees. So that's 3.605. So this side length is equal to 3.605. It says rounded to the nearest tenth, so I go to the hundredths place, that's a 0, so rounded to the nearest tenth is 3.6. Now, one way you could do it is you could also do it with the Pythagorean theorem, and I can show you those steps. So with the Pythagorean theorem, we would have a squared plus b squared plus, equals c squared. So what is A, what is B, and what is C? Well, C is always the hypotenuse. A and B are side lengths, so I'm going to just again let this be A and let this one be B. So then I would use this Pythagorean theorem equation and I would substitute in the values I know. I do not know A. I do know that the value of B is 6 and that the length of side C is 7. So then we would have A squared plus 6 squared equals 7 squared. So I could simplify. 6 squared is 36. And 7 squared is 49. So then how would I solve for A squared? We would want A squared to be by itself, so we would subtract 36 from both sides, and 49 minus 36 leaves us with 13. So we would have A squared equals 13. So now how do you undo a squared? You use the inverse operation, which is square root. So we would square root both sides, and the square root of A squared leaves us with A, and then we would have the square root of 13. That equals 3.605. So either way, you end up with the same side length. I just found that the trig functions can be faster than the Pythagorean theorem. So that is something to keep in mind if you're like, Pythagorean theorem is the way to go, it's my go-to. That's a great tool to have. Maybe consider using a trig function. It can be faster. Like this one was 1 step and this one was 1, 2, 3, 4 steps. So that's why I would suggest that. Now, moving on, now that you know side length BD, you can use this to find the segment of BC because BC is equal to 2 times the length of BD because BD is half of its length. So if this is 3.6 and this segment was the same, because remember when it was given, this said it was a segment bisector, so that means it cuts this segment in half. So this is also 3.6, so 3.6 plus 3.6 will be 7.2. Alright, review the following solution for the area of triangle triangle ABC. Area of triangle ABC is equal to AD times the length of AD times the length of BC times the sine of B. Area of triangle ABC is equal to 6 times 7.2 times the sine of 59 degrees. So the 7.2, remember, is the side length that we found. And the area of triangle ABC is approximately 37.03 units, which statement is true regarding the previous solution. When I look at these steps, there's one thing that's coming to mind, and anything that has to do with an area of a triangle will always have 1/2. So they are incorrectly using this. The other thing that I use is I use my tricks and tips, not really tricks, but they're just tips on how I remember this formula. So one of them is when I'm dealing with the area of a triangle, it's always half, because a triangle is half of a square or half of a rectangle, so I'm always going to be taking half. The other one is when I check the side lengths compared to the angle. I first identify my angle, and then the side lengths are the ones that sandwich in that angle. So the side length of BC and the side length of AB sandwich in this angle, or they're the ones that are the segments attached to this angle. And that is how I help myself remember this formula. So as I'm comparing, AD is not a side length that sandwiches in this angle, so that's incorrect. BC is a side length that sandwiches in this angle, so that is correct, and our angle is given, so we have matched it. So the side length AB is the one that it ought to be in for AD. So I'm looking for that, I'm looking for 1/2, and I'm looking for AB instead of AD. So that's how we go through this first question.